Okay, so this is going to be your warm-up. Before we start that, know that tomorrow is your requiz at lunch. Obviously, I'm not here today for you to tell me if you have a conflict and can't come Wednesday at lunch. You need to either email me or send me a message through Remind with your name and class period to tell me what your conflict is and what your plan is then for taking the requiz. If you do not have a conflict, the only chance for taking the requiz is tomorrow at lunch. You must have corrections on separate paper and staple them to your original quiz. That is your ticket to take the requiz. Okay, we will pause the video here for you to try the warm-up. I'm going to try to make it a little bigger so you can see the scale. Okay, so for number one, I'm first going to figure out the amplitude and the midline, which will give me the K value. So the middle is here at -3. And that means then the amplitude is the length from there into the max or the min, which is 4. The period, I'm going to go from here on the y-axis to when we start again. So the period is pi, which means the b value is 2 pi over pi, which is 2. And now I can write my two equations. Oop. So I'll start with the sine graph because there's no horizontal shift. Then I'll do the cosine. Here's a maximum, so that's 4. Move to the right, pi over 4, and down 3. For the second graph, our midline is at -1, and the amplitude is 2. The period is 4 pi. To go from max to max is 4 pi. So I'm going to start with my cosine graph. Oops, I didn't find B. Because there's no horizontal shift for the cosine, but now for the sine, I want to look for where the graph crosses the midline and goes up to a maximum. So that happens here to the left pi. So this is page 31. Today what we're going to do is use the sine and cosine functions to model real-world problems or phenomena. So it's going to be all word problems for the most part. We're going to start with another Ferris wheel. Oh, it's the same one with Carlos. And we have the same criteria for that Ferris wheel. A radius of 25 feet. The center is 30 feet above the ground. Counterclockwise every 20 seconds. And he starts on the far right. So the amusement park Ferris wheel is located next to a high-rise office complex. At sunset, a rider casts a shadow on the exterior wall of the high-rise building. As the Ferris wheel turns, you can watch the shadow of the rider go up and down along the surface of the building. In fact, you know an equation that would describe the motion of the sunset shadow when the angle of rotation is measured in degrees. This is going to be a height on that building. So if we have 20 seconds is one rotation, we have to figure out how far we'll go in 1 second. So if we divide this by 20, we get 18 degrees per second. So writing our equation just like we had before for the Ferris wheel. So at noon, when the sun is directly overhead, a rider casts a shadow that moves left and right along the ground. So when we did this, that was a cosine function because it was horizontal. Okay, so we're going to write the equation for that. And there is no vertical shift up or down because a shadow is along the ground the entire way. So now what we're going to do is change these to radians. So if it's 20 seconds for a full rotation, that's 2 pi radians. So if we divide both sides by that 20, in 1 second we go pi over 10 radians. So we're just going to change that 18 in each equation to pi over 10. Okay, this is page 33. This is very, very similar to your homework last night. So we will pause the video here for you to try numbers 1 and number 2. Okay, so for number 1, my midline is at y equals 0. And the amplitude is 2. And the period, okay, so notice the x scale is in integer values, 1, 2, 3. So what I've labeled is a little past 3 is pi, because pi is 3.14159. So if we look at one rotation of the wave, the period is pi, which means the b value in my equation is 2. My sine function has no horizontal shift, so I'm going to write that one first because this is the middle and going to a max. But for cosine, I need to figure out where is this maximum. I know that our graphs are split into five equal critical values. Middle, maximum, middle, minimum, middle. So that means halfway is pi over 2, and halfway again is pi over 4. So then my cosine graph is moved to the right, pi over 4. Oops, did you catch my mistake? That should be a minus for right pi over 4. All right, so let's do that all again for number 2. If you got stuck on 2 because you didn't see this scale, we'll pause the video here for you to try number 2 now, that you can see what I have typed on the x-axis. Okay, so the midline is at y equals 2. Which means the amplitude is 1/2. And the period, alright, so here's the maximum to a maximum. Oh, we can find what's halfway, because the minimum's here at pi over 3, and this minimum's at pi, so this maximum must be halfway, and it's definitely, that does not go to 2. So if I do pi plus pi over 3, that's 4 pi over 3, but then I have to split it in half for the midway. That is going to be 4 pi over 6, which reduces to 2 pi over 3. Okay, so the period is 2 pi over 3. Another way that you could have found the period is found the length between pi and pi over 3. So my cosine function does not have, oops, I didn't find b, doesn't have the horizontal shift. All right, I need a b value. So let's see, b is 2 pi over the period. Like that's the same as multiplying by the reciprocal of the denominator. So that's a 3 for b. And then my sine function, okay, so I want midline going up. So let's figure out where that happens. Actually, if I do midline going down to a minimum, I can then reflect my function, so I'll put a negative leading coefficient. And this is halfway between pi over 3 and 0, which is pi over 6. All right, our last page together is going to be page 35. So we have a new Ferris wheel. It has different parameters for us. It has a radius of 40 feet. The center is 50 feet off the ground, and we make one rotation counterclockwise every 18 seconds. Write the equation using radians if the rider starts at A. Okay, so the center is 50 feet off the ground. So that is our horizontal shift. I'm sorry, vertical shift, up 50. The radius is 40. And then I need the b value from our period in radians. So if it takes 18 seconds to go one full rotation, if we divide both sides by 18, we do 1 second in pi over 9 radians. At what time is the rider 70 feet above the ground? So we're going to write 70 equal to our equation. We have to solve this. So your test is no calculator, so we can do this with no calculator. And we'll divide both sides by 40. So we get 1/2 equals sine of pi over 9t. So with no calculator, the only other thing that you can do is do sine inverse of 1/2, which will equal pi over 9t, and then multiply both sides by 9 over pi, and that is going to be an exact value for the time. Well, that doesn't really mean much. So let's take out our calculators and figure out what that is. Make sure you're in radian mode. And if you type that in your calculator, you should get about 1.5 seconds for time. Okay, if you use the sine function, which we did, let's do the same thing and rewrite it as a cosine function. So the only thing that's going to change is a horizontal shift on our graph to when we are at a maximum. So we have to figure out at what time will we hit the maximum of the Ferris wheel. So if it's 18 seconds to go all the way around, that's 9 seconds to go halfway, and then to go halfway again is going to be 0.45 seconds. And we have our cosine graph. Oh, sorry, cosine equation. Okay, so your homework is page 37 and 38. You can use the rest of the class period to work on that now. Make sure to check your answers in classroom tonight and be ready for your requiz tomorrow at lunch.